Look at binary coded decimal. Please don't get confused with binary conversions. This binary coded decimals is a bit different than your normal binary conversions. I'll just tell you something becomes easier for you to understand. Imagine you have a secret code where you can only use two symbols on and off. That is basically how computers store information, but with on being 1 and off being a 0. This is your binary numbers. Now numbers in your game is 0 to 9. It's pretty easy to understand, right? But if I take a number like 14 and to try to convert into binary code, it becomes difficult for us to do it, because if it is 14, then to convert it to binary, it is 1110, right? So at the time, because it's a small number, it becomes easier for us to remember and do it, but when it becomes a larger number, it becomes difficult. So the binary code decimal is like a cheat code for your computer. Instead of turning the entire number 14 into a difficult binary mess, BCD takes each digit separately and converts them into separate binary code, and this is a 4-bit binary code. The 4-bit we also call it as nibble. So let's take 1 and 4. So it is 0001 and 0100. Now this becomes 1 and 4, so with the combination becomes 14. Let's see what binary code is. Okay, a BCD code is commonly used in digital displays. We call a 7-segment display. Now these kind of displays are you'll find commonly in public places. Like if you go to railway station, your indicators have these kind of displays. Now if so these displays can make your numbers from 0 to 9. They use it to form a numeric data, as well as it can create alphabets for displaying the data. So this is known as a 7-segment display. Now I'll show you how this the 7-segment display looks like. BCD is not only used in 7-segment display, but it is also used changing analog to digital signals. Okay, so how does the analog to digital signals? We have already seen that how does the analog to digital signal look like. So this is how it is commonly used. Now let's look at what are the advantage and disadvantage of your binary coded decimal. The main advantage is that it's easier to convert and it's readable, and it's simple decimal arithmetic. What you do it, what you find in calculators and all, or public places displays. Now it uses these kind of things. The disadvantage of this is that when we are storing this data into 4 bits, the amount of memory it will take is too much. That's why it's not feasible for use. But yes, for limited usage, these BCDs are being used. You can pause the video and you can read through it, what is written there. Okay, now I just want to tell one thing which I haven't said, that now when I say 4 bits of numbers, okay, when you have numbers, 4 bits of numbers, 2 raised to 4, when we say 2 raised to 4, it becomes 16 numbers. But we do not use 16 numbers, we use digits from 0 to 9. The rest of the numbers are known as unwanted numbers in BCD. Let's see the conversion. So let's, the number is 356, convert into BCD. So let's take 3, 5, 6. So 3, if you take it, it's 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 0. So let's calculate. So the number you have is 4 plus 2, 6, 4 plus 1, 5, 2 plus 1, 3. Combine both the numbers. We don't add, we combine the numbers, or we say we concatenate the numbers. So it's 3, 5, 6. Let's take another one. So here I am taking a decimal number. Now here, do not get confused with the binary conversion of decimal numbers. Okay, BCD is different than that. BCD is just a coded form where we take each number in isolation and convert into binary. So let's take 0, not doing anything. 2 and 6, 0 1 1 0, 0 0 1 0, and this is 0. Okay, so let's take the same thing again, calculate it. So what are the numbers? 1 and here, so this becomes 4 plus 2, 6, 1 here is 2, combine them is 26. We do not have anything, so we say 0.26. So here the number is. Now let's look at reverse of this. So let's take a BCD. So we said nibbles, this, so 0 1 0 1, 0 1 0 1 1 0. Okay, so 4 plus 2, 6, 1 plus 8, 9, 4 plus 1, 5. Combine them, so the answer is 596. Let's look at last one. Separate. Let's take the number separately. 0 0 1 1, 1 0 0 0, 0 0 0 1. So this here is 1, so answer is 1. Here it is 8, so 8. This is 1 plus 2 is 3. There's a decimal point, so we say 3.81. I hope this video is helpful to understand what BCD is. Thanks.